AI is evolving fast. Are you ready? Meet AI at FlytBase, your weekly hub to learn, upskill, and stay ahead in AI world. Let's dive into today's session.
Welcome to another AI in Action session. We still do have people joining in, but before that, let's just go by a general round of introduction. Hi, I'm Shruti here. For those of you who are new, welcome to this AI in Action. FlytBase does a lot of AI initiatives, and we do post about that on our growing WhatsApp community. We do have more than 1,500 members out there. So do join in to keep yourself updated with what's happening in AI and also at FlytBase. So that's about it. Like how it goes, let's start with the AI news. So for today, I have something interesting. In the VLM world, we have seen a lot of models coming in, but recently we did see Gemma 3 come in. Let's wait for my screen. Yeah. So Gemma 3 has come in. It's come in with the most multimodality, feature where it can understand images, where it can understand text, it can understand videos, and it has longer conversation levels as well. So you can have longer conversations with it, and it can analyze all your short videos, images, and text. So it's a beautiful capability that has come up. Do check it out. And then we do have ByteDance, who has come up with this model called Dolphin. It is a document passing framework that converts all your PDFs into structured formats so that you can run it through any LLM. So you don't have to worry if your PDFs are not being run by LLMs or not. And then we have the next one. So basically, Chrome has announced its Chrome DevTools MCP. This is basically, I think, what Saurav showed almost 2 weeks back, where he had done an entire automation, debugging, testing, and everything using Playwright. And right now, even Chrome has come with its Chrome DevTools MCP, which will help you do the same things. So something crazy, something to look forward to. So let's check it out. The last but not the least is that obviously GPT-5 codex is on Visual Studio now. So for those of you who are using Visual Studio, I mean, yeah, you've got your GPT-5 codex right now. So that's it from the AI news section. There's more to come, but you'll find out next week. That's it for today, but I would like to introduce our speaker for today, Mahesh. Hi, Mahesh.
Hi everyone.
Hello. Mahesh would be running us through few of his insights from few of his insights and hacks that he has discovered from, doing our latest products. So, Mahesh, over to you.
Hey, thank you, Jyoti. So, hello everyone. I'm Mahesh, working as a senior software engineer at FlytBase. Hope you have seen the today's title. I have modified it a bit, so give me a second. I'll present my screen. So, as you have seen, like today's title is more about the deep tech building AI applications. So, let's get to the why I modified the topic to building and deep tech AI applications from the actual beyond token limits is we all have worked along with the chat LLMs and some sort of basic like visual builder tools like N10 or any others that you can think of like Langflow, Flow AI. So like when you start working with APIs and building the AI applications, then you start feeling the like the need for optimization and a lot of other challenges that you start facing up. And like we are building kind of a deep tech product from past few months, and now we have those learnings, and I'm today here to present some of those learnings and key insights. So I will walk you through the agenda. So we'll be like seeing what a problem statement that we were solving upon and how we stumbled upon the solution that today works in production. We'll see a journey of it, so we'll get to learn more things from it. Then we see the challenges along with the uh, solution evaluation, and at the end we'll see some learnings and we can have a quick snap of what we have built yet. So let's move forward. The About the problem statement. So as a flight base, we capture a lot of drone data. Like it includes images, videos, and time series analysis of the data. And now with this data, people need some insight. So let me give you an example. So how it works is, let's say for you are in a security provider. Now you use drones to do a security of large areas, like let's say large commercial buildings which are spread in acres. Now it's kind of quite difficult for humans to go and check out on security. So use drones as an aerial view cameras. Now with the data that you have captured, you would like to have an analysis. If let's say, for example, some people are jumping over the gates in an unrestricted area and odd timings. So, like if your drone captures that, you need an alert notification to be generated so that your operation teams can go, as well as you will need that in your like forensic reports or diagnostics reports so that you can present it to the higher authorities for any further actions. So now consider this as our problem statement that we were working upon. Now the goal is, like if you see, there are a lot of moving pieces in this. The data that is being captured by drone is the first source to identify actual event. Then once you have the data, now you will need other metadata such as flight history, who was flying the flight, like what was the conversation that had happened when the pilot was during the flight, and all those things to be combined to generate an collective insight. Now this becomes a kind of a Gen AI problem where you start hitting scale and limitations with the state of art models and things. This is what we are going to discover today. So I will walk you directly through the solution page. Hope you guys are catching up with me. Can I give a quick heads up? Yeah, thanks. Great. In the solution evaluation, let's clarify, let's amplify the problem statement that we're working upon. We'll get a lot of data sources, image, videos, text, conversations, and now we want to turn it into an insightful reports, which include the incident analysis. So this is the simple problem statement. Now to come up with a solution, we started with a basic LLM prompting and text inputs to get initial version of it working so that we have a confidence that the problem statement works actually, and a Gen AI helps to solve that problem statement. So I'll get you to the details. So I'll be presenting few iterations, and along with iteration, we will get the learnings that we had. So in the iteration one, as I said, we were, if you see my Excalibur screen, I have few diagrams on it. So the iteration one is on the screen right now. We have input, which includes images, text, as I said. Then we have a processing engine, and this processing engine is pretty simple. You have just LLM, VLM, and some prompts configured, and you are running it, let's say, by a LangChain, LangGraph. We chose LangChain initially. So, and you have output and report. So I will walk you through the example output, how it looks. Then you will be able to relate it more. So the final output looks like this as the one of the comprehensive reports that has come up from an incident. So these are kind of in general report that are being made in enterprises for let's say for a security perspective, they will need incident. For it, if it is an inspection perspective, you will need inspection summary. So these are quite of observations that had happened. You have those images aligned with him. Further observations. So these are the images from oil industry. So this application is used across industry, security, oil inspection. So it's mostly for report generation from various data sources. And this output is being returned by LLMs. So it's not something that you can get directly from ChatGPT. It involves a lot of data sources to be included in. And this is the final output. But I wanted to walk you through the output so you'll be able to better relate what we are doing upon. So in the iteration one, as I said, we got like a POC to be working, and we got to know that Gen AI works really well for the application that we have chosen. And now we move to the iteration two. Now things started like we need more customizability. We need a lot of data sources to be included, such as I said, we need flight data. Images is the one source which is getting into as an input directly, but we'll need a knowledge base, because if you are inspecting something or if you are finding security uh, issues, then you would know, you need to know these security norms of that particular organization, which includes that you are having now a knowledge base. Like as human beings, we have our own knowledge base built over a period of time. Now agents needs to have that, so we started moving from just raw LLMs and API calls to actual agents, which can call now tools, which can have access to MCPs, because they will need to access our databases, need to fetch data from it according to user request. And now the processing engine started evolving to an agentic system. Still it's an single agent system. Now the data source as an input also started becoming more rich. Like along with images, text, users are now giving the instructions as well as the background for given incidents. So and now what challenges we started facing from here? So if you see from an architecture point, like it's an overload for a single agent. And the report that I've shown you, it's very simpler and shorter version. Now, the report that are getting generated in the enterprise are 50, 60 pages long, and which is equivalent to 4,000, 5,000 simple raw lines of text that needs to be generated, and which is quite difficult from an LLM API perspective when you are starting working with it. The reason is there are token limits on APIs, on actually model input output processing. So for input, it is understandable that there is a context window, what you can put into the context window. That is one challenge. But apart from the context window, now the major challenge faces is output, because on output you have very limited output rates. So like if you get the best model today, like Gemini 2.5 Pro, Claude Sonnet 4, or even GPT-5. All of the GPT-5 has increased to 128K, but it's like state of the art model, which are okay, fine, perform better today, have output context limit of 65K. So they can emit max tokens of 65K at one time. This is one of the issues that we started facing up. Now, also another issue is knowledge base. So we have a knowledge base as a RAG databases, but we do have time series data. We have a lot of structured JSON data, which is kind of an not suitable for like putting into an embedding, do an embedding and put it into vector database and use a semantic search, because JSON are not that suitable for embedding databases, and we needed that as a knowledge base. Now such problems we started facing up. So we evolve our solution to the iteration 3, which we today use, and it works well in production. So our inputs is still same, but our processing engine now started evolving. Now the single agent system has become a multi-agent system, because single agent has too much overload. Like understand user context, then fetch the knowledge base, collect data from different tools, then get the template for user report, and then start preparing a report to draft. So a lot of work for any single agent. Now introduce multi-agent system. Currently, our system has 3 agents. It's like primarily one is an orchestrator agent, which as well as it has the knowledge base. Both the agents has knowledge base, and third one is the actual final report prepare engagement. So which actually takes the content, logical content, and start filling it into the template that user has given. Because the report that I've showed you is pretty templateized. So like if you generate 100 reports, it will look same at all costs. So it's like you are having a human being which is generating a reports for your organization, because enterprise has the same structure to generate reports. So this is how the tabletization works. Now, so what we have introduced to solve the challenges that I showed you, first one was the running out of tokens. So both in input as well as in output rates. So we introduced a context engineering module in our processing block. So like we wrote our own algorithms for it to manage what to put in context window. Because consider like when you work with a chat, or let's say when if you are building an intent flow, it's just that you put like what generally you don't care about the input context window until you start hitting it, and you start putting anything into context window. So what we have saw when we like ran through the traces of the LLM calls that we found a lot of things that were going into context window are irrelevant, like not that relevant and affecting to the output. So we need to do a lot of evals to understand what is required actually in the context window, which helps us. Like initially we had almost 80K, 100K going per call in a context window. I'll get to another problem that leads to get into this. So, consider 80K going in a per call, and such 10 to 12 calls are happening within a single report to an LLM. So, consider the large amount of context that we are putting and the cost that are coming up, because every token that you add in an input and output, you'll get a cost for that. So, yeah, I'm explaining the context engineering module itself. So now our input content input tokens has been dropped from 80K to 5K to 10K max. And this is what an optimization of a context engineering module looks like. I'll not be going through the algorithms of what we wrote actually, but I'll explain the process. As I said, you need to debug and see what is getting input as a context window within the API calls, and now you start doing an eval over it. Like if you there are in a context window, there are some like block kind of structure that follow, we follow, like some memory, some instructions out there, then some data input sources, some metadata IDs, and so on and so forth. So we started experimenting, removing some things, doing evals, checking out the output quality, and removing the unnecessary part from the context window, and which helps us to drop actually to the optimized context window. And this is what context engineering started to evolve. There are a lot more to do in the context engineering part, but the stage that we are in, so we are having pretty optimized solution today because we have dropped from 80K to almost 10K, so which is great in optimization. Then another things comes up is as I said, let me browse through problem statement list. They are pretty big. So the second one was related to the data processing as well as. So in knowledge base now, consider as a big enterprise, you have a lot of SOP documents, lot of security related your norms that you have made, your organizational knowledge, your like the site that you are operating at, their knowledge. So it's all documented and put in like this is one kind of text form of knowledge which you can easily rag it using vectorized databases, and you can query semantically. That is not a big problem. But problems start evolving when you have time series data. You have JSON kind of data, which is not that suitable to convert into rag, because for JSON parsing, it's pretty hard. You start matching how you start matching the semantics and so. And our use case, like time series data is one of the key incident, because like whenever you fly like a drone, you have an incident and which has time series timestamp. Like at time T0, person A started checking on the gate. At T1, it jumped over the gate. Now this is kind of an incident timeline, and you would need that timeline within your report. And like how you will query that. So generally we use document databases to store like such kind of JSON and document data. Now to retrieve that, we build our own tools around it. So majorly, I will give you the name, like JSONata is kind of an utility library built over the JSONs. Like you can like query through large JSON easily. Like it's heads up on the top of database queries. Now you got a lot of data from databases. Now how will you query the particular data? Because if you put like 1,000 line JSON into the context window and it has only a relevant chunk of 10 lines, it's unnecessary context. So we have to introduce our own tools based upon JSONata, which the one of our agents calls to process and get the relevant data from the knowledge bases. So this was the second level of optimization that we reached in. Then performance issues and debugging and reliability. So when you start working with actual API calls, you start hitting the, as in our case, as I said, like the end output was 12,000, 15, like 12K, 15K lines of actual JSON, which converts into a text that you have saw in a report. So to generate that 12K lines of JSON, now it's impossible to go and even do it in it's impossible in a single API call, first of all. So we had to split that into a batch processing kind of thing. And even if you split into batch processing, the time that has it was taking up to generate an output was 2. So we had to like go to a software 1.0 classic approach, how using multi-threading into this. So you start now getting into the actual software problems apart from just the LLM outputs. And for traceability as well as evaluating modeling, it's important to know because these are probabilistic system. It's not a software 1.0 where like your written code is like a logical that it will work 100% times until it has a random bug. But in a probabilistic system, now you have control with the help of LLM. So it's not like even if have a prompt, it's not that 100% that prompt output will be same as previous. So it's going to change upon how it's accessed to how it access MCP. And now you need a tracing initially to understand how your prompt diverts the output. So, and for that, we have heavily used LangFuse. So it's one of the observability tools. So to get a detailed traces of what's going in input context window, how the intermediate state has processed. So yeah, that was one of the learnings. So you will need an extensive observability for